not only are you going to need to be able to find mean, median, and mode, discuss mean, median, and mode, describe mean, median, and mode, you're going to need to be able to discuss these in a larger picture because people don't want mean, median, and mode. They don't just want mean, median, and mode. And in fifth grade, sixth grade, whatever, like you're just given a set of data and you're told find mean, median, mode, and range. And here you have to start to think about the data and what these descriptive statistics mean for your data. People might not have access to your data. In a realistic scenario, you're going to collect data. It might be hundreds of data points. It might be thousands of elements. You may not have the luxury of looking at a data set and drawing conclusions. So the important thing is to be able to report a measure of central behavior. And when we're looking at this web here, this is sort of how the notes are outlined. So if you wanted to do a web or an outline, you can do that. So the definition of central tendency, we're going to really talk about it here. And then each measure of center, we're going to talk about not the definition of them, but when you should use which one. Let's just get started. So what is central tendency? Central tendency might sound scary because maybe you didn't really think of mean, median, and mode in these terms before. So we're going to break this down word by word. Central means having to do with the center. It means that something's essential or pivotal. And then tendency is the likelihood, inclination, or disposition. So you need to think about this as which measure, mean, median, or mode, best describes a data set's tendency of center. Which mean, median, or mode is going to describe your data set the best? So you think about this as average behavior, but I don't really like to lead with that because average means mean, and I like to use maybe the word typical behavior. So let's define some things and then let's look at this in a more practical way. Central tendency, you can write this down, statistical measures that reveal the central behavior of data, the typical behavior of data. How can I boil data down into one number that's kind of summarizes like the most likely or like central or like center behavior of the set? Mean, which we know as the average, is best used when data is grouped close together. So if there's no outliers, there's nothing surprising about the data, and we'll kind of look at examples of that. When there is outlier behavior in a set, mean is not always the best measure. It's not always the most responsible measure because mean is not resistant to outliers, and I am going to show you what I mean by that. Median is the middle value numerically. It's best used when your data does include an outlier. So median is resistant to outliers. Mean is not resistant to outliers. And I will show you, I promise, I will show you what I mean. And then mode, get my mug out of there. Mode is best used when all elements are exactly the same or when you have qualitative data. Most likely in this course, it's going to be when you have qualitative data because mode is really just not used as prevalently as mean or median. Okay, so if we look at two data sets here, and this is hopefully going to illustrate this idea of how like mean is not resistant to outliers and median is resistant to outliers. And again, it's tempting because you start to see like you have a choice, like, oh, I could tell you average, and then whichever mean, median, or mode makes my conclusion look better. You can use your statistical powers for evil, but responsibly, we're gonna adhere to these general rules. Okay, so which data set should you opt to use the median to report central behavior rather than the mean, and why? So this is ounces of tea. And so in 5 days, this person drank a 16 ouncer, a 20 ouncer, 20 ouncer, 22 and 22. And then in another, that says 6 days, but it really supposed to be 5. So another person It's supposed to say 5. I'm not going to fix it now. No. So just pretend in your mind that this is 5. So another 5 days, 6, 16, 20, 22, and 22. So if you notice, these sets are pretty similar to each other, except it looks like one of the 20s is now like a 6. So let's just see how that affects the central tendency. So if you find the median, it's the middle number. These are already reported to you in order, which is nice. So the median of this is 20, and the median of this is 20. So in this case, it's like, okay, well, that seems good, right? It's fine. Don't really know anything about our central tendency right yet. I don't expect you to like have any earth-shattering revelations here yet. But if we find the mean, 16 plus 20 plus 20 plus 22 plus 22, divided by 5, that's actually also 20. The mean here, 22 plus 22 plus 20 plus 16, instead of adding another 20, we're adding a 6. And the mean is now 17.2. This is how I want you to think about this. The median and the mean for this set is both 20. And I would hope that you would agree that this person typically drinks about 20 ounces of tea on any given day, right? Based on the pattern, based on the data. Maybe 16 is like a lower day, but it's not really considered an outlier because it's close to 20 and it's really only 4 ounces shy. And then for this person, though, you have this outlier of 6 that's dragging your mean down, right? And you think about this too, like you live your life under these circumstances. You get all B's on tests or on all your assignments, you're getting a B, everything in the grade book is a B, 80s, 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 and then you get like a 60 on a test. What does that do to your mean? Your average, that brings it straight on down. So you need to know that the mean is very easily skewed by an outlier behavior. Because this person had 6 ounces of tea in one of the 5 days, then we know that the mean isn't really representing the rest of the tea drinking behavior. And I hope that makes sense. So in this case, you might be thinking like, all right, well, 17, that's close to 20. Like, it's fine. Like 17 is pretty close to 20, but that's not what I need you to think about. I need you to think about how does 17.2, 17 ounces fit in with this data? Okay, 17.2 is smaller than 60% of the data. 17.2 is lower than 3 out of 5 of these data points. That's low. That's pretty low. Like you can't really say that 17 is a good representative number of this set. Because there's an outlier, the mean is no longer representative of the set, so therefore the median, which is resistant to the outlier behavior, the median is safer to report. Hope that makes sense. You should probably pause right now and just like let that marinate because we're going to go through some examples. All right, age of people in a classroom. Oh, lots of 14s, 15, 13, and 59. 59. Seems like an outlier. So in this case, you have age of people in a classroom. You have one outlier, a big outlier. So as soon as you see that outlier behavior, your answer officially here should be, I'm using the median because I don't want 59 to make my mean too high and make it look like these people on average are older in this classroom. So if you said median, awesome, boom, good, great. Your explanation should be because there's an outlier. Okay, off to the side. Some people see this and they're like, oh, wait, but earlier we said mode. You could use mode if most of the data is the same number, and that's totally true. So if you look at this and you see, oh my gosh, like almost every single number is 14. Yeah, I see 59 here. Almost every single number is 14, some 13s, some 15s. I'm just going to say mode because it's the number that's obviously overwhelmingly most occurring, and it makes sense. Okay, so you could have said median, you could say mode, but your explanation is going to dictate whether you're correct, ultimately. Favorite soda. All right, this is qualitative data. categories, labels. We can't take an average of this. So we would go for mode for this one, because there's nothing else you can do. You can't find the median and you can't find the mean. And median is numerical. So don't tell me that you can put these in alphabetical order or something and then find the median. It's not going to work that way. Hours of TV watched yesterday by 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 people we surveyed. Cool. Okay. So it looks like we're between 1 and 4. And then we have this big old 10. Somebody watched 10 hours of TV yesterday. Maybe they were sick or something. They took a sick day. This one with the outlier automatically, I know the mean is going to be skewed, and it's going to be skewed toward the 10. The 10 is going to make the mean too high. So I'm going to go for median here, and that would be my explanation. Would be, I see an outlier. Median is resistant to outliers. I will use an outlier. I will use median because there's an outlier. Number of pages in books at the Brandywine Wallace Elementary School Library. So it looks like somebody 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe they just grabbed 11 books randomly, saw how many pages were in that book, wrote them down. This is a nice quantitative data. You can take a meaningful average of this and talk about the average number of pages in a book at the Brandywine Wallace Elementary School Library, blah, blah, blah. So we have 60s, we have 70s. There's no outlier behavior here. And there's also not an overwhelmingly repeated number. So I would just use the mean, just classic, find the average, done. Okay, this is going to be a twist because I'm asking you to hear for this, use your statistical powers for evil instead of good. So if you had these test scores and your parents are like, hey, how you doing on your test performance recently? What's the situation? And you're like, oh yeah, no, my typical behavior is whatever. So you could first see, okay, well, once at a glance, there's 5 elements in this data set and they're in order numerically. So that's good. So finding the median is 74. And then when you find, so that's okay, like 74. All right, fine. So 68 plus 70 plus 74 plus 77 plus 93. We're going to divide that by 5. So not that it like helps you too much, but you can either tell your parents that you're, achieving sort of like a solid C, or you could be like, 76.4, which turned out to be the mean, and you can make yourself look just a little bit better. Every little bit helps, I think, when you're trying to convince your parents of things. So that would be what makes you look best, would be the mean, so the median was 74 and the mean, which is 76.4. The mean would make you look best. And the reason for that is because you have this outlier, and the outlier just skewed you just a little bit higher on the mean. And the median is still 74 because it's resistant to outliers. I think we have one more and then we're going to summarize. So the minutes spent working out yesterday, we have a lot of zeros. We have 20s, 30s, 45, 60. In this case, I think that there might be an argument for a couple things, but see, if you say mode, like the mode is 0 and the mode is 30, that doesn't account for, if you say the mode is 0 and the mode is 30, people are going to think that it's on the lower end, but you have people out, exercising for more than 30 minutes. So in this case, I would go for the median, only because there's 2 modes here and the median is 30. And that makes sense. So if your lowest is 0, your highest is 60, right in the middle is 30, and you have 4 people exercising for 30 minutes. So I would say that's reasonable there to say median. So to summarize, the mean is the average. Mean is not resistant to outliers. So if there is an outlier, do not use mean. Only use mean when your data is really nice, when it's all kind of grouped together, there's no outlier behavior. Median, if there's an outlier, boom, just use median because it's most likely going to be more accurate than mean because of the outlier. The median is resistant to outliers. Mode, most of the time it'll be qualitative. I'm going to lean on that side of the definition here for mode, and it's going to be more rare to really truly decide that mode is the best. I think something is different about the scenario that you're in. And when you're in doubt, find all 3 and then look at all 3, find all 3, look at all 3 numbers and then look at the data and then say, okay, well, I'm, using your common sense. Well, mode, median, mean, which one of those seems to represent all of the data? If I got rid of the data and if someone said, you only can tell me one number, which of those one numbers do you think would best represent the data, most of the data, the central behavior of the data? And then arguments can sometimes be made for more than one measure. So having an explanation with your answer will show whether your thinking is accurate. When you have the opportunity to explain, include an explanation.